All right, Nico, let's get started. So Nico's there manning the booth there. You can see that's not Kendall, anyone who knows Kendall, and he's one of our marketing interns for the summer, and he's gonna be helping us out on the back end here. So go ahead, Nico.
Yeah, so today's the first session for Mintek Resources Spring Webinar Series. It's focused on lime and soil stabilization construction applications. And today we'll be talking for about 45 minutes. And at the end, there'll be a Q&A. So feel free to drop any questions that you have during the webinar into the Q&A box at the bottom of your screen. We'll also be sending out the PDH certificates to those of you who requested the PDH credit. You can anticipate receiving your certificate tomorrow. Like Phil said, my name is Nico Marsh. I'm a marketing intern with Mintek Resources. I'll be helping Phil today on the back end of things. I'd like to briefly introduce Phil, then I'll hand it off to him to start the webinar. So Phil is our customer application specialist here at Mintek Resources, and he has worked in the industry for over 11 years. He has experience in material testing, including construction, environmental remediation, and soil stabilization technologies. With our parent company, Calciment Americas, he has specialized in hands-on testing, method specifications, customer applications, and technologies associated with limestone and lime production, such as quicklime, hydrated lime, lime kiln dust, milk of lime, and other associated materials. So with that, I'll hand it off to Phil, and we can get started with today's presentation.
All right, welcome everybody to another installment of Mintek Resources Presents. Today we will be starting off the first portion of our complete course on lime for construction site soils, or as we here at Mintek like to call it, our Lime 101. So like Nico said, my name is Phil Belcastro. I'm a customer application specialist with Mintek. And with that, let's take a look right at the agenda. So we're going to talk about who exactly Mintek is if you're not familiar with us before we start talking about different terms associated with lime, because lime can be a little bit tricky out there. Then we'll get into the meat and potatoes with the products we offer and talk about how they interact with the soil. We have two other courses, if you will, that we'll be doing one every month in these coming months. So the second one there, Lime 201, the next course we'll be talking about different application steps and different rates associated with them. General DOT specifications and some considerations. We'll keep it high level because I think we've got a pretty wide audience here. Then we'll dive into kind of differences, similarities between lime and cement and see when one might be advantageous to use over the other. Final part of our course, more data-driven, third-party testing, some notable projects that we've done, dive into a little more detail on a couple of them with some case studies before we wrap up with some frequently asked questions that we've come up with over the years. So with that, for over 25 years, Mintek has been the premier supplier of reagents used to dry, modify, and stabilize unworkable soil, sediments, and waste. We're headquartered in Beaver Creek, Ohio, and I myself am based out of our Pittsburgh location where we have Calciment Americas headquarters and our innovation center where we've got our labs, soils lab, chemistry lab, along with microscopes in our microscopy lab. In April of 2018, Mintek was acquired by Calciment. So Calciment is a leading provider in lime and limestone products. We help make the steel around us stronger, the air we breathe cleaner, the water we drink purer, and today we'll be concentrating on how we can improve construction site soils. We've served customers nationwide, but we'll really take a look at where our focus is in a couple slides. Mintek is the exclusive supplier of Calciment LKD, and we also can supply quicklime, hydrated lime, some Portland cement, and blending capabilities as well. We're known for our unparalleled reputation of service and support. So what does that mean? Maybe some technical sessions like we're in right now, or some pre-project planning where we get our sales folks involved. Got a strong logistics team there in Beaver Creek, so would help us with quick quoting and delivery. Multiple packaging options, normally pneumatics, but dump or some bagging capabilities as well, so we can get the material you want, where you need it, when you need it, how you need it. So like I said, for over 2 decades we've been at this. But we're not just talking, well, today we're talking about construction, but if you ever find yourself in a position where you need to dry or improve some material, chances are that the Mintek Carmuse family has done it, or we have someone who is knowledgeable in that area. So feel free to reach out to us and see if we can help each other out. So here's a quick look at our distribution network, our different plants that we have around. You can see kind of our focus is more east of the Mississippi, with a couple outliers going west that way. But we're really starting to grow to meet the needs of you folks out there, our customers. And we've really developed a nice team here. So we've got Carmuse, we're the huge lime supplier, the limestone producer. We're really good at producing high quality product and shipping those large quantities to stationary locations. For example, US Steel literally takes tons and tons and tons of material day after day, but we're sending the same amount of material, same amount of trucks to the same locations. So we're really good at doing that. Now, on the other hand, Mintek is kind of our construction service and support arm. So we know how to serve those customers on a daily basis. We understand the construction market and we can service it very well. We know that jobs get pushed, weather happens, things like that. So really we formed a nice cohesive unit together. We have a nice team to serve our construction needs. So speaking of team, here's another team, the sales team that I pull on a lot, very knowledgeable. If they can't answer a question, they can reach out to me and I can reach out to any of my lab guys if I can't reach it or if I can't answer it for you. And we also have Jennifer and Brian that are more or less based out of our Beaver Creek office. Brian's a little bit further west, that is. But really a great team that we can pull from here. So jot down some contact information or feel free to reach out just as you did on the registration side, we can get a hold of us. All right, like I said, to the meat and potatoes of the little webinar today. Lime terminology, for anyone out there who's new to lime, was expecting to talk about this today. This is not what we're talking about today. We're not talking about anything related with fruit. Okay, when I say lime today, what I'm referring to is quicklime, calcium oxide. So right off the bat, I want to also say that we are not talking about ag lime or agricultural limestone. It doesn't share those chemical properties of the quicklime that we're looking for. So I know it can be a little confusing, but right off the bat, not ag lime. So when I say lime, we're talking about quicklime, like I said, calcium oxide. It can be referred to as high cal, burnt lime, hot lime. If we have a portion of magnesium in there coming from dolostone, makes it a dolomitic quicklime. Just has, like I said, magnesium present in there, calcium magnesium oxide. So those are my quicklime terms. More products that are out there. Whenever we add water to that lime, we hydrate it into hydrated lime or calcium hydroxide. That process is also called slaking. So it's slaked lime, Mason's lime, hydrated lime. All those terms are once again associated with that hydrated lime, calcium hydroxide. If we increase the water content even further, we can make more of a milk, milk of lime, like it says right there, or a lime slurry. And Carmuse also offers a cal-safe product that's really good for the environmental side for Carmuse. So just pointing that out there, there's different products depending on kind of what's involved. And then back to Mintek, if we add some pozzolon into it, that's where the lime kiln dust comes into play. And we've got a great product, our Calciment LKD. Really, like I said, is good for us. And we'll get into how those pozzolons get into the product in a couple of slides. So once again, what we're not talking about today is simply limestone, calcium carbonate, magnesium carbonate. Those things will help us, maybe in construction for aggregate base course or riprap, things like that. Or for our farming friends, the ag lime, barn lime, lawn lime, all those terms are associated with just pulverized limestone. So not going to help us in the construction world. They'll help them amend their fields and get some nutrients to those crops. But remember, that stone does not share the same chemical properties as the lime that I'm talking about today. So getting right through it to our product overview. We take our limestone, we cook it in our kilns at a high temperature for a really long time. We're going to force off that CO2 and we're going to be left with the reactive oxide portion. So many, many, many years ago, this is what they made lime in. This is an example of a beehive kiln, but we've progressed, and here's what most of our kilns in our network look like today are rotary kilns. But We're starting to progress even further than that. And now we have what's called PFR kilns, or parallel flow regenerative kilns, or simply known as a vertical kiln. So that's what you're seeing back in the background between the silos there. Kind of a cool picture. I couldn't pass that one up. So we're kind of progressing, getting greener and greener, more and more efficient as well. So that calcium oxide, that lime, is a highly reactive product. So I like to pause here, just a quick note about safety. Wear your eyeglasses, long sleeves. This stuff will react with water. We'll talk about that in a little bit, but that lime doesn't care where that water is coming from. For example, sweat around your neck or cuffs of your sleeves and gloves, for example. If it contacts that water, it's going to start to react and could burn you. So just be cognizant of that. Some barrier creams could help if you're out there in the field, especially maybe some windy or dustier conditions. Additionally, it'll take your breath away. I carry a respirator in my hard hat, so just help me get out of those areas if I need to. Comes in a couple different sizes there, pebble versus fines. Some other industries like to use the pebble. On the construction side, we'd like the fines, 3/8 by 0, 1/4 by 0, things like that. Smaller particle size means increased surface area, which helps us for the reactivity. So why are we using it? It absorbs water. So quicklime, for example, will absorb over 30% of its weight in water as it hydrates from calcium oxide to calcium hydroxide. And we talked about that heat before, about the possible for the burns on your arms or any exposed areas if you're wet. So that exothermic reaction will help to drive off additional moisture in the form of steam on that site. It's a very exothermic reaction. We're going to improve those engineering properties of the soils. We're going to improve the plasticity. We're going to eliminate, reduce, if not eliminate, the shrink swell potential, and really make for an overall improved bearing platform. If we add enough material to the soil, we can generate permanent long-term strength gains with some pozzolanic activity that we'll get into in a couple slides as well. So it's a really great product for that as well. Hydrated lime. So now we have our calcium oxide. We're going to add just the right amount of water and agitation to quench that reaction. And we're going to be left with calcium hydroxide, or hydrated lime. It's a very fine, low density material, kind of small particles there. So we use it for some of the same reasons we would use the quicklime, to improve those engineering properties and stabilize the soil for us if we add enough to it. And also worth mentioning here, not exactly what we're talking about, but still in the construction world, used as an anti-strip for asphalt as well. However, it has a reduced drying capacity. Hydrated lime, like we said before, has already been hydrated. So not as much drying action. It's still a dry bulk powder, so you'll get some drying from it, but not nearly as much as the quicklime or Calciment LKD would. Regional and seasonal availability. For example, in the South, a lot of that material is locked up from September to January for sugar processing, and we only have some of these hydrators in certain areas, so that's where the regional comes into play. So just something to keep in mind if we're working with anyone who's specifying only hydrated lime. Maybe we can get a larger conversation going about being able to utilize the benefits of quicklime. Dust concerns, we mentioned it's a bulk powder. If we're in urban environment or windy conditions, just something we need to be aware of. To the Calciment LKD is where our pozzolans come in. So it's a co-product of our lime manufacturing process. It's a mixture of the calcium and magnesium oxides that we talked about, plus these pozzolans. Now they're coming from the fuel that we use to fire a lot of our kilns, and they're captured and built right into the product. And so it's a nice competitive alternative between the quicklime and Portland cement that kind of bridges the gap between quicklime and Portland cement conducive soils, more granular soils versus very fine grained soils, the clayey soils. So we're using it for the same reasons. Once again, improve those engineering properties like shrink swell potential, better compaction, getting some long-term permanent strength gains as well. But why do we want to use these products? So anytime we got our crews out there stuck in the mud, not getting any work done, no productivity, I want you to think about lime. Want to improve some of those engineering properties once again. Maybe we're having some rutting issues on the site. Here's a picture of me pre-COVID days out in Chicago. We were getting some benefits of soil modification, but we're really just trying to dry the soil with the quicklime. And of course, my obligatory equipment stuck in mud picture, probably a little extreme, definitely needs some site drainage, probably some operator training as well. But really, anytime you've got difficult working conditions, consider lime and lime products. But without a doubt, one of the main reasons we get calls is, hey, I've got my loaded triaxle out here. We are failing our proof roll. My field tech's out there with his nuke gauge saying we're nowhere near OMC. What can I do? So you can do what some folks did years ago. As you can tell, this is a newspaper excerpt cut out from a newspaper. And so these folks down in Gainesville, Florida, they were trying to dry an area for a parking lot for a Ryan Steakhouse, and they actually hired helicopters to, I guess, try to generate some wind currents and help to dry things out. So probably not your safest, probably not your most efficient use. And I don't know if they're necessarily related, but that Ryan's is no longer in business. So maybe they spent a little too much money trying to dry up the soil in unconventional ways. So back here in the real world, what are our options? Well, you can wait. As the name implies, it's time sensitive. You never know how long you're going to have that nice dry weather to help to dry out your soil. Meanwhile, while we're waiting, we've got equipment sitting idle. We hear it time and time again that site superintendents will say, hey, I'll give you a couple thousand for soil stabilization over a couple days of my yellow iron sitting any day of the week. Another option, we could disc it. It's cheap. Chances are that equipment is sitting in a neighbor's farm field somewhere close by. We're just kind of helping Mother Nature do its thing. We're opening that soil up, folding it over itself. Meanwhile, it's once again weather dependent. If it should rain again, now we've opened up that soil for a whole, similar mess, just probably a deeper mess at this point. And speaking of depth, we can really only treat 4 to 6 inches, and we're really only going to reduce that moisture content by 4 to 5%. So another popular option out there is absolutely the remove and replace. Get that junk out of here and bring in some stone. I would argue that that's expensive. It's slow, got a lot of truck traffic associated with that, and the safety concerns that come along with all those trucks. We have to find that material. Where are you getting that borrow material from? I know those borrow pits are getting more and more scarce, and we got to haul out that wet, weak soil. So that's costing us money too. We've got to find a spot to dispose of it. So the last column here, my personal favorite, the chemical stabilization route. I'd argue it's fast. We minimize the need to borrow material. We might have to top it off with a little stone at the end. We don't need to dispose of any soil. We can improve on what's already there. We can bring in 1 truckload of lime, treat the initial problem, and move on, rather than bringing in 20 truckloads of stone and hauling out that same amount of material. So really, lime stabilization improves on what's already there and is the most cost-effective option, the value engineered option. So we ran some numbers over the last couple of years, and we found 50 to 70% savings using the lime stabilization method. Compared numbers on the remove and replace to the chemical stabilization. Those numbers included, on the remove and replace side, the cost to excavate and haul that wet, weak soil, import some soil, compact it, and top it with some stone. Compared to the chemical stabilization side, spreading it, mixing the material, compacting it, and grading. And once again, 50 to 70% savings, so some really nice numbers there. But a little bit of a backstory, those numbers are a nice threshold to keep in mind is 20,000 cubic yard projects. By the time you get that specialized equipment in there, the soil reclaimer we're looking at in the middle, a nice experienced crew that knows what they're doing, at 20,000 cubic yards, a nice threshold to keep in your mind. And we don't mean to deter any newcomers looking to help spread lime in some areas that need it. So if you ever find yourself in that situation, we're happy to be out there first, second time as you start to cut lime to see the benefits of it. But either way, whenever we add our lime products to the soil, 3 things are going to happen. We're going to dry, modify, and stabilize. So with that, let's get into the interactions. On the drying side, the video you're seeing, we have a medium plasticity soil, probably I think about a 16 to 20 PI, and we're adding pretty standard application rate of 4% quicklime to it. And we're going to mix that up. While I'm talking, we can see kind of the action that's happening. We're going to start to dry that soil and also modify it. We'll talk about that also. So what's happening here as we dry the soil? We are using that water that is naturally in the soil, which we don't want to be there. We're going to use that to hydrate our calcium oxide, our quicklime, to calcium hydroxide, our hydrated lime. So as that chemical reaction is happening, it generates a lot of heat. We talked about an exothermic reaction. So that's exactly what we're seeing in that picture on the left. That's that cold day in Chicago pre-COVID. We were out there in the freezing temperatures, keeping this project going. Our spreader truck had already went by, spread our application of lime. The water truck is there in the background, and before the soil reclaimer can start to mix the lime with the soil, the reaction has already started. It's a great thing to see out there. The folks on the site can see that they're getting the benefit right off the bat. So that, because that's actually steam, not dust that you're seeing in the picture. So like I said, very exothermic reaction. We like to, we have an example where we actually fry an egg. We're using just lime and water. The right or maybe wrong proportions of lime to water can generate some really, really impressive heat. So as I've been talking on the slide for 1.5 to 2 minutes here, we can already see that that soil is getting much more friable, much more workable. We can see some of the action happening in that bowl. But I want to point out those hands you're seeing right now. Hands that belong to some of our guys in the lab. That's Steve Totoki. Steve, along with Mario, have mixed lime with pretty much everything. Steve has literally built runways on lime-treated soils around the world, from the Philippines to frigid Antarctica. This guy is built on it as a member of the Naval Seabees, the construction battalion. So feel free not to only to pull on myself, but we can pull on these guys. They know the methods inside and out. They're happy to explain them. We're happy to get out there in the field to help out and really share what we know. So once again, as I've been talking, we can see the action here. It's really dried out that soil and produced a much, much more workable soil that we can start to build on. So from soil drying, now we're looking at soil modification. Modification, we're going to physically change the soil. We're basically going to make an engineered fill material. Now the soil modification really affects the clay portion of the soil. So the more clay, the more modification possible. So a lot of folks, when they're out there on soils, they start to see clay and they kind of get scared, but really that's where it's time for lime. That's where we live, in those clay soils. We can get in there and help to improve those soils. So this little cartoon I put together is a little animation of the clay particles. You can see a large amount of water that's being held, because that polar water molecule likes to hang around those negatively charged clay particles, really stick together. They're generally orientated in a edge-to-edge orientation, where you can imagine all of that water around the particles is just acting as a lubricant, just allowing things to slip and slide around. You know, you can imagine putting a load on that, not going to be stable at all. Additionally, whenever the clay is wet, it's going to swell, and conversely, on the other side, as it dries out, things are going to shrink. So that difference in volume, not good to build on, right? Well, as we add lime to the soil, a couple of things are going to happen. First off, cation exchange. The calcium from our lime is going to come in and displace other cations like sodium and potassium. And that's going to help things rearrange, because those charges, everything's not happening at the same time. Difference in charges is causing the rearranging of particles, or as we call it, molecular flocculation and agglomeration. Love saying those terms. And that's going to rearrange things to more of an edge to face orientation. So you can think of like a house of cards, rather than them being like a flat deck where water is just trapped in there. Now we've rearranged them. We've opened up that space. There's more room for any water, so we wouldn't have that change in volume, the shrink swell. And that rearranging is generating friction, and that friction is going to give us strength. So it's making a much more friable and workable soil. So that's what else you were seeing in that video. Not only did we dry it, we made it much more friable and workable. So what's that going to do for us? We're going to reduce the plasticity. We talked about shrink swell potential and really going to give us some better bearing capacity. So it's not some voodoo magic. You can imagine taking this ball of soil, squeezing it in our hand and oozing out through our knuckles. But now we've treated with our 4% quicklime in the lab. You can see the molecular flocculation. It's there. You can see the individual grains on the screen. Pretty cool. And this happens pretty much immediately. So in the lab, that was just a couple minutes. Out there in the field, really about 4 hours is what we say. We like to get in there and let it work, let it mellow, let it do its thing on the quicklime side. On the Calciment LKD side, there's no need for that mellow period. So, but it's the effect that you can see out there really quickly, almost immediately. So we talk modification and drying. We like to talk about the net effect. And the best way to show that is through a moisture density relationship or a Proctor curve. So each one of those points is an individual sample compacted at different water contents. So that's on our x-axis. Dry density on the y there. And I like to explain this curve as like a walk on the beach or think about making a sandcastle. Got to get that right water content to the soil. So as we start our trip up the curve here, just getting to the beach, not nearly enough water on that dry sand. Our feet are just not stable at all. They're sinking and sliding into that dry sand, or in my case, soil. And then we work our way to that peak there. We found our perfect spot to drop all our gear. We're gonna build our sandcastle right there because we have just the right amount of moisture to give us prime compaction, but really hot now. We got to get to the water to cool off. Way too much water under our feet now. We're slipping and sliding. That's what's happening kind of on the far end, the far right. Way too much water in the system. So that's a quick analogy on the Proctor curve there. That's our untreated soil, so in situ soil. But now we've treated it with, in this case, 4% quicklime, and we've shifted that curve. So we shift it to the right, so we're going to be able to accommodate more moisture at the time of compaction. Think about where our optimum moisture content is right there. Say if we're trying to dry it back from 25% moisture to close to 20, 21 there, we've got a smaller gap compared to the untreated soil where we got to get back closer to the 15. So we can accommodate more moisture at the time of compaction. I'm also going to drop that curve down, making compaction easier to hit that maximum dry density. So the net effect, what's that all about? I got 3% just from the drying alone, where we're combining with the water, forcing off more in the form of steam. Our 4% increase in OMC, that rate, both these kind of vary on conditions, how much you're putting in, what's in the soil, but some general numbers here give us about a 7% net change in moisture content at the time of compaction. But very important, field operations, we got to target the right point. We got to target that modified soil OMC. So it's important to at least do a 1-point Proctor out there to see where you are, compare it to a family of curves, or if you got the time in the lab to do it, a number of points to generate the full curve. But really, we got to target the right point there because we don't want to be drying things back too far where we're missing that OMC and maximum dry density. Once again, think about that sandcastle. We need the right water content. So what's all that going to do? It's going to keep things on track, reduce the downtime on the production side, and help to hit those time numbers. So what's all that mean? So nowadays, everyone's data driven. We're no different. So we're looking to see what that modification has done for the soil. So we looked at several soils across our region. We were targeting more of the clay stuff. You can see some fat clay, some lean clay, probably some silts sneaking in there. But either way, low CBR numbers, the California bearing ratio. We wouldn't want to build a sidewalk on this, let alone a highway. So we treated it using the ASTM method, the standard 4-day soak before the penetration testing. And you see we got some great results. Over 4-fold in some, we got 4 to 40, 3 to 40. So some great results right off the bat. And I'll try to toggle back and forth because I had to mess with the scale to kind of help us see the real benefits. So you can see, once again, some great results. And what's happening here is just from that modification. We're immediately adding strength from that friction from the rearranged particles, that edge to face orientation. So we talk soil drying, soil modification, onto soil stabilization. This is where we're looking at the long-term, the permanent stability, those pozzolanic reactions that are coming from the pozzolon-rich environment that helps us form cementitious bonds over time. So speaking about quicklime here, it's an alkaline material. We're going to raise the pH of the soil and allowing the amorphous silicas and aluminas, those pozzolans, to become soluble. We're bringing calcium to the table with the lime. We're going to form calcium silicate hydrates and calcium aluminate hydrates. Those same sort of bonds you're going to see when you're working with Portland cement. We're going to develop those same sort of gels, just like when we add water to Portland cement. So on the Calciment LKD side, we are supplementing those pozzolans. There might not be as much clay involved in those soils. So it's a great, like I said, a great product that kind of bridges the gap between those lime conducive soils and the cement conducive soils where it's more sandy. So what that's going to do is it's going to help us form a solid monolith. We're going to have lower moisture absorption. And then for any of us like me in the freeze thaw areas, we got that nice freeze thaw resistance, increased durability associated with that. And as long as we have those ingredients, the calcium, the pozzolans that are soluble or supplemented with the Calciment LKD, we're going to continue to gain those strengths over time. We've got a cool lab experiment we'll probably highlight next time that just keeps, that shows those strength gains continuing and continuing. Then that last point I'd like to point out is the potential for reduced pavement thickness. The subsequent layers can possibly be thinner if we are able to take into account the strength that we're going to see in that subgrade level. And that's going to save contractors money, save DOT money, save those virgin materials, good for everybody. So take a look now at those same samples we were looking at before. And now we're going to we did a little extra study. We cured these CBRs for 7 days, just like we do for other accelerated cure tests, to mimic the results over a longer period. And then we subjected them to the standard 4-day soak and penetration testing, and we see we got some great results once again. So we had already modified and rearranged those particles, but now the only thing adding to the strength during this time period is those pozzolanic reactions. And with that, the course is basically over, folks, so pop quiz time. Unfortunately, I can't hand out any paper, so we're just going to do a quick review. So of course, Mintek, we saw that we've got the service and support. We can get the products where we want it to be, when we want it to be, how we want it to be, not just for construction. Mintek's environmental side, oil and gas. Anytime you're trying to dry or improve some of those properties, please keep us in mind. We of course looked at lime terminology. What is lime? Well, don't be afraid to ask someone who's saying that they're using lime. What are you doing? Is it quicklime, hydrated lime? Is it ag lime? So difference between all three, and of course we're not talking about the fruit. The products we went through, we've got our Calciment LKD, nice gap between some Portland cement and quicklime. And like I said, we have quicklime, hydrated lime, some Portland cement capabilities along with blending capabilities as well. And then we went into the soil interactions. We're going to dry it. We're going to combine with the water that might be present in those wet, soupy mess, those sites that we're often on. Also going to force off additional moisture in the form of steam. On the modification side, edge to face or edge to edge orientation of those clay particles, rearranging to the edge to face, the modifying, basically making an engineered fill material. And then soil stabilization, where we're really pulling on those pozzolanic bonds that we're forming with when we introduce our products to the soil. So with that, Lime 101 is a wrap. We got it done, check mark. 201 and 301 to come. Please join us. We're doing one a month. And if you stick around and join us for all three, you can get I think a pretty sweet swag pack, or a chance to win that is. Amazon gift card, a nice polo, and a Flex Fit Mintek hat. So pretty cool there. So with that, please mark your calendars, and I'll open up for some questions. I'll check the chat window, and I'll let Nico and anyone else on the panel, if we have any of my sales guys join, we can open it up for some questions. And with that, I'll probably stop sharing so I can get into the chat mode. All right. Nico, can you hear me?
Yeah, I can hear you.
All right, cool. So did we see any come in through the chat window?
No.
I don't think so there. So now's a great time. If you got any questions, happy to run through them. I think the best way is to probably type them in the chat window. I don't think with this platform we can unmute everybody. I think we chose to keep everybody silent because the last thing you want is someone's dog barking in the background the whole time. So feel free to shoot over any questions. We'll give it a moment. If not, thanks everybody for joining. Appreciate it. I looked earlier at some of the participants logged in, some familiar names. So thanks to you guys, and some of the names I don't know. Looking forward to meet you out there sometime soon, hopefully. Give it one more moment, see if anyone pops through. Oh, here I got one. How do I determine which product is best for my site? Kind of a tricky one. You know, you get one of those answers, well, every site's different. One of the best resources we have is the lab right outside my office where I'm based in the Innovation Center. We are happy to prove out the solutions. We can try our Quicklime, we can try the Calciment LKD. Last thing we want to do is present you with a material that is not going to work on your site, not good for anybody. So we're happy to prove those out. You know, a couple samples to, like I said, prove it out. We're not a production lab like some of the folks I saw on the list here, but we're happy to prove out those options. Feel free to go with your sales guys, get samples our way. We can talk through what you're seeing, what your problems, what's your goal. So that's one of the best ways I can tell you is lab work, but it also depends on the application. What are you trying to do? If you're simply trying to dry it, depending on material availability, I don't want my sales guys to slap me, but the Quicklime and the Calciment LKD are great options. Which one can, it can be kind of a play on the price at that point. So I would hope you would reach out to some of your sales guys, but if you're drying hands down all day, every day, the Quicklime, the Calciment LKD are the best drying options out there. What is the biggest, another one coming through, what's the biggest cost impact for the product and implementation? Example, transportation of product, the product itself, the install cost, etc. Jim, if you're able to come off mute, I might call on you. I was wondering if you're able to. On the cost side, like I said, I don't want to get slapped for answering on the cost. One of the, I know the equipment out there is very impressive, and I understand it's one of the more expensive things to have on the construction site. But as far as what's the most expensive, be it material, the equipment, the trucking, I know trucking's getting more and more expensive, so trying to do some work on my back end. Thanks, Jim. Jim, I think I made you available to talk if you can come off mute, but if you're not able to, that's fine. Feel free to read us. Oh, there you go. Yeah.
Read me the question again, Phil.
It actually disappeared on my side, but what it came down to was, hey, where's the most the cost coming from? If I understand the question correctly, is it trucking? Is it material itself? Is it the crew to put it in? So I think what's the breakdown? Can you help me kind of relay where the costs are headed?
If you're going to hire a crew to come in with the spreader trucks, the reclaimers, the mixers, etc., the personnel, you know, everything that comes into that part of it. Quite honestly, the the cost per square yard using, or the cost per square yard with quicklime calciment is a relatively small fraction of that overall cost. I mean, it's don't get me wrong, it's to some degree a product that is not the cheapest thing to buy in the world, but at the same time, when you look at it on the cost per square yard, even cost per cubic yard, it's a relatively low number. So I would say, again, if you're looking to, bring in an outside contractor to do all the manipulation, spreading, except, and for that matter, it depends on how somebody breaks it down as far as what the contractor is going to take care of, as far as the compaction, the grading, etc. Or is that also left up to the so-called stabilization contractor? Because you can break it down a number of different ways with those kinds of contractors. So, but again, when you look at the overall cost on a cost of lime, cost of calciment per square or cubic yard is a relatively low number in the grand scheme of cost.
Thanks, Jim. Appreciate you chiming in, hopping on. Yeah, I've heard that before. It's a drop in the bucket at times, for especially some of those large projects. Got a couple more questions that came through. Terry, I'll do yours next. This one, have owners, parentheses, DOTs, accepted, modified, and manipulated different types of clay, the fat clay, lean clay, if the in situ material is unacceptable per the contract. DOTs are definitely a little harder. I don't have an example on the top of my head for DOT work. I know we've done some work where we were able to modify, say, like some A6s or A7 soils down to where the liquid limits had changed enough where we had changed the plasticity index where it was then classified as an A4 soil. So we were working to basically modify that soil into something that would be acceptable per the contract. So the short answer for me is yes, with a caveat that on the DOT side, they're always a little bit more strict. So Jim, you're still off mute if you want to chime in at all with that, but I know that we have modified some soils to make them acceptable, yes.
I'm not familiar with on a Q. I don't know what a Q curve is, but moisture content was about 4% over optimal moisture. Any thoughts?
So you're hopping ahead to the next question. So that question is, hey, I think everyone can actually see that one. So the test plugs there from Terry, again, some low PSI. Any thoughts at 4% over OMC?
My only thought was there a moisture, well, let's just say, was there a treated proctor versus just an untreated proctor done? Because again, that we know that to be true in the field a lot of times that there's not, and you have a geotech out there who's testing, your moisture contents, and he's coming up with, it's whatever, it's still over, but is it really, and you had a slide in your presentation to show you the so-called net effect, right? So, one of the things, always be sure to check with your geotech, particularly in the field, if you're not seeing a reduction in your moisture content via the Newt gauge, be sure to ask the technician or somebody within that geotechnical firm, is there a treated proctor that is that moisture content from the treated proctor or untreated proctor?
Yep, I echo all that, Jim. Appreciate it. Yeah, the net effect comes to mind here. Terry, happy to get with you on the side. There's no lab test at all, just showed up on site. Make plugs. I think the more lime is needed. Yeah, like I said, we're happy to, maybe we'll talk on the side, see what's going on, but 4% over OMC, just going real high level here. That's no problem for the quicklime, hopefully to drop it down 4 points. But I'll give you a call after this. We can talk through and see what you got going on. I know Tim is out in Columbus today, so he might even have a little more info. We can loop him in on this too if you want, Terry. Appreciate the questions so far. If you got any more, drop them in. So that's all I'm seeing so far, folks. Appreciate you joining. Got the dates up there, June 28th and July 19th, same day of the week, Tuesday, same time, 3 p.m. Eastern time where I am as well. So please join us. Like I mentioned before, chance to get that swag pack, as my marketing friends are calling it, if we join all three, and we can work on getting those PDHs out if you request them as well. So with that, I'm going to wrap up Lyme 101. Thanks for joining once again. Take care, be safe out there. Thanks.